If you've ever tried building a custom API pipeline to feed live data into an AI agent, you know exactly what this looks like. You spend weeks engineering custom connections across different platforms, only for the results to fracture. You map the endpoints, set up authentication, and finally get the data flowing. Then, a single platform updates its API structure, and your entire integration breaks overnight. To solve this, developers are adopting the Model Context Protocol, or MCP. It replaces that chaotic web of point-to-point connections with a single, open standard that unifies how AI models access external data. You no longer have to build custom infrastructure from scratch just to let an AI read a database. Open standardization does the heavy lifting. To deploy this at scale, teams use Vinkius. It operates as a massive managed gateway, holding a catalog of over 2,600 pre-built, production-ready MCP servers that you can connect immediately. This transitions AI agents from reading static text to executing queries directly within your enterprise applications. Because it's fully managed, you skip the Docker containers and course configurations. You deploy a server with one click and get a clean server-sent events, or SSE, endpoint to plug straight into your client. Connecting an enterprise tool in minutes shifts your engineering resources away from infrastructure maintenance and toward orchestrating agent behavior. To really test this architecture, we have to look at one of the most notoriously locked down environments available, learning management systems like Moodle. Educators and academic analysts usually face heavy friction here. Just checking student enrollments, cross-referencing grades, and tracking course completion requires clicking through layers of clunky dashboard menus. But by generating a Moodle Web Service token and pasting it into Vinkius, you connect your entire Moodle database to your AI agent in under 2 minutes with zero infrastructure setup. You bridge natural language directly into a closed database, letting you manage the system through conversation. Let's say you prompt your agent to identify which students haven't completed their latest quiz. It autonomously retrieves the course ID, cross-references enrolled users, and pulls the exact completion status. Next, it checks gradebook data for those falling behind. Without ever opening the Moodle interface, the agent can instantly send a direct message to those specific students to offer help. Powered by 10 distinct tools, the AI operates as a proactive academic assistant, capable of multi-step orchestration across your courses, managing enrolled users, and student grades. Directly feeding student names, IDs, and grades into a large language model introduces liabilities regarding data privacy and regulatory compliance. To handle this, Vinkius runs on a zero-trust architecture, built specifically to comply with strict regulations like GDPR and the EU AI Act. Before data leaves, a data loss prevention mechanism intercepts the traffic, masking personally identifiable information so the LLM never sees raw data. Each request executes inside a sandboxed V8 isolate that spins up in milliseconds, logging everything to an ED25519 audit chain. And because of secure credential injection, your Moodle API keys stay locked in the infrastructure. They are never exposed to the AI model itself. This level of invisible, rigorous governance is exactly what makes deploying autonomous agents in the real world possible. Because Vinkius supports standard protocols, this secure connection works with any MCP-compatible client you already use, whether that's Claude, Cursor, Windsurf, or a custom build using the OpenAI SDK. And Moodle is just one environment. It sits alongside over 2,600 other hardened, governed MCP servers, ready to deploy on day one. To start building, go to vinkius.com, create a free account, generate your MCP endpoint, and paste it into your client. The friction of custom integrations is gone. Success now depends on how well you orchestrate the